So for this video, we'll be discussing the Statistics 2 paper from May, June 2023, then variant 2, right? So this is paper 6-2. Okay, so let's have a look for question number 1. Okay, so in a survey of 200 randomly chosen students from a certain college, so 23% of the students said that they own a car. They want us to calculate approximate 93% confidence interval. So I think you need to highlight the keyword confidence interval for proportion. Okay, so of the students from the college who own a car. So when they're asking for the confidence interval for proportion, basically you need to know the general formula for the confidence interval. Right, so for proportion, basically the formula is P plus minus Z, then multiply with square root PQ over N. Okay, so this is your general formula for the upper and lower limit for the confidence interval. Okay, then to answer this question, they're asking for the 93% confidence interval for proportion. Okay, so first of all, I will want to substitute in all the values. So the lower limit is P minus Z square root PQ over N. And then for the upper limit will be P plus Z square root PQ over N. Alright, okay, so for these formulas here, basically we are having some values already, where I know the P is the proportion, which is 23%. Alright, so I'm having 0.23, and then minus the Z. Okay, so for the Z value, basically we have to find out from a normal table to decide the Z value. Okay, so before we decide the Z value, we need to know that for any confidence interval, right, we are interested to find the value of Z, then the 93% is actually in the center, the graph, which is 0.93, the area here. Alright, and then we are having the value of Z, which is this one, and also this negative Z. Okay, and then if we try to separate all the area here, right, divided all the area here equally for both ends, so I still have 0.07 divided by 2, then this area should be 0.035. And this is also 0.035. So that when you add these two sides together, you will get 0.07. And 0.07 and 0.93, you get a 1. Okay? Then to decide the value of Z, I need to find out the Z by using the area of this whole part in red color. So this whole part is 0.93 plus 0.035, where you are getting 0.965. So to get the value of Z, you need to refer to the area 0.965 from the normal table to get the value of Z. Right? So let us go back to the table, normal distribution table. We are looking for 0.965. So where is 0.965 basically? So we have to look for the area from this side. Okay, where they denote area, and these are the values for Z. Okay, 0.965. Okay, just to double confirm, 0.965. So okay, so come again. So looking for 0.965, I think the nearest number to 0.965 will be this one, 9649, right? Okay, so this 9649. When you read the value 9649, going out to get the value of Z, it is actually 1.8. And then the value on top is 1. So you're having 1.81. And after that, 9469, you need to add a 1 at the last digit so that you can get 9650. So to add a 1, you are having two possibilities here, which is the value 1 or 2. Which means that your value of Z should be equals to 1.811, okay, or 1.812. Both also acceptable. Okay, so let's go back to our question here. Okay, then the Z now, I already know that it is 1.811 or 1.812, up to you. Okay, both are accepted. So substitute in the value here. P is 0.23. Q basically is 1 minus 0.23, right? So 1 minus 0.23, you have 0.77. Then divided by N. So what's the N here? N is 200. We are having 200 randomly chosen students. So the same thing happened for the upper limit. Okay, but we change the minus become the plus now. Right. Okay, so 0.23 multiplied with 0.77 divided by 200. Okay, so once you know how to get the value of z correctly, then by using calculator, press all the value out, okay, then simplify your final answer, correct to three significant figure, your answer should be 0.176 and also 0.284. Right, so this is how we answer question number 1. Okay, so now we come to question number 2. It is given that the random variable W has a Poisson distribution, and then they want us to state the relationship between the expected value of W and also the variance of W. Okay, so by right, you should know under the Poisson distribution, right, the mean and also the variance of the variable should be having the same value. So that means my expected value of W, which is the mean, should be equals to the variance of W when the W is a Poisson distribution. Alright, so this is very straightforward. Alright, then now we go to part number B. So for part number B, they are saying that the random variable x has a binomial distribution. Okay, and then Jyoti wish to use a Poisson as an approximate distribution of x. So that means they plan to change binomial become Poisson. And then they want us to use a formula for ex and also variance x to explain why it is necessary for p to be close to 0 for this to be a reasonable approximation. Okay, so maybe let us start with the binomial first. For any binomial distribution, right? Okay, what is the formula of mean for binomial distribution? It should be NP. And then for the variance for the binomial distribution, okay, it should be NPQ, N times P times Q. Okay, and then when I want to change binomial become Poisson, okay, so when I want to change binomial become Poisson, right, the parameter inside here is the mean, which is N times P. And now they want us to discuss why when I want to change binomial become Poisson, the P must be close to 0 so that the Poisson is a reasonable approximation. Okay, so now we try to link it together with the Poisson now. Okay, so just now in part number 1, we know that if I want to change the x become Poisson, then the mean of x will be equals to the variance of x, right? Okay, so what's the mean of x? N times P. What's the variance of x? N, P, and Q. So for the Q here, I try to rewrite it again become P lah. So it will be 1 minus P. Q is the opposite, the probability for the opposite event or the complement event of P, right? Okay, so Q will be equals to 1 minus P. Okay, and then if I want to change it become Poisson, the mean should be equals to the variance. How can I make the mean equals to the variance? So from here you can see, if mean is NP, then I also hope that variance will be NP, which means that this particular part here should be almost equals to 1. So if I want to let 1 minus P almost equals to 1, right? So that I can get NP equals to NP, then you can see that P should be equals to 1 minus 1, which is equals to 0, which is nearly close to 0 lah. That means if your P is small enough, alright, then basically you can get the better approximation so that you can get mean of the x equals to the variance of x. Alright, so that's the reason why you need to make sure that P close to 0, that only you will get a reasonable approximation from binomial to Poisson. Okay, so that's the reason. Alright, so maybe you can write out one more information here where you can see here if P close to 0, okay, then 1 minus P close to 1, then the expected value of x will be getting closer or equals to the variance of x, where we'll get a better approximation from binomial to Poisson. Alright, okay, so basically this is the idea. Okay, then now let's continue to part number C. Right, so for part number C, right, they are saying that, okay, now I'm having the y with binomial distribution. It is they want us to use a Poisson distribution to calculate the estimate of y greater than 2. Okay, so at first, I'm having, it is not x anymore, it should be a y. Binomial distributed with 20,000 and also this probability. So to change it become Poisson, I need to get the parameter for Poisson, right? The parameter for Poisson here is a mean or lambda. Okay, so to get a mean or lambda, basically you're taking n from binomial distribution, multiply with the p from binomial distribution, then to get the lambda, which is 1.4 for this case. Okay, so just to recall back, this is actually n times p lah. So n times p, you get the mean, which is the lambda, and you get a value for lambda 1.4. And now they want us to calculate the probability for y greater than 2. Okay, so for y greater than 2, for Poisson distribution, right, we're not able to calculate the probability by using greater than, because if you are mentioned greater than, that means you have to start from 3, right? Y equals to 3, y equals to 4, y equals to 5, until y equals to infinity. When go to infinity is a lot lah. So that means if we want to make our steps easier, you have to take 1 minus the probability of y smaller equals to 2. Okay, so how to get the probability for y smaller equals to 2? So 1 minus e negative lambda. Then the first one is lambda. The first one is also a 1. The second one is always a lambda, 1.4. Then the third one is 1.4 squared divided by 2 factorial. This is a shortcut formula where this probability is actually x equals to 0. And then after that, this probability is x equals to 1. And also this is actually x equals to 2. So I want to take 1 minus, not x, it should be y. So 1 minus y equals to 0. 1 minus y equals to 1, and also 1 minus y equals to 2. So this is a shortcut formula for the Poisson distribution. Okay, and then after that, by just pressing the calculator and try to get an answer, you should get 0.167, correct to 3 significant figure if you didn't do any careless mistake here. Alright, so this is how we answer question number. Alright, so now we come to question number 3. We are having the masses in kilogram for newborn babies is country A, and then represented by random variable x. Okay, then with mean, mu, and also variance, the mass of random sample of 500 newborn babies in this country were found, and the results are summarized as below. So we are having a sample from country A. Okay, so a sample of 500 newborn babies. So these are the summary for the country A. And then they want us to calculate the unbiased estimates of mean and also the variance. Unbiased estimates. Right, so when you're talking about unbiased estimates for mean and variance, basically you can get the formula from here in our MF19 booklet. So this is what we have, unbiased estimator for mean and also the unbiased estimator for variance. Alright, so according to the value that we get here, right, summation of x and also summation of x squared, if you try to refer to the formula here, so the more suitable formula for variance should be this one. There are 2, right? So I think this one will be more convenient for us. And then for the mean, basically it is the same like what we find all the while. Summation of x divided by n. Okay, so basically this is a formula that we have. So maybe we can try to print screen and then try to copy this formula here. Okay, so just for you to refer, this is the formula that we have, right? Okay, so to calculate the unbiased estimator for mean, you need to take summation of x, right, which is 1625 divided by the summation, divided by the n. So n will be the 500, and therefore you get the mean, which is equals to 3.25. Okay, so this is the unbiased estimated mean for the population, right? Then after that, I want to get the unbiased estimates for variance. Okay, so to get the variance, according to the formula that we have here, it should be 1 divided by n minus 1. Okay, so our n is 500 minus 1, I get 499. Then I'm having summation x squared. Summation x squared is given here, 5663.5. Minus the summation of x squared, where it should be 1625 squared, divided by n, which is 500. Variance here, it will be good if you keep it in a fraction form lah. If not, it will be very long, the answer. So for the fraction form answer, I will get 1529 divided by 1996. Okay, so this is quite a straightforward question, right? You just directly get the values, okay, by substituting the answer, the value into the formula. Okay, then now let's proceed to part B. Okay, so for part number B, they are saying that there's a researcher, right, wish to test, so highlight the keyword test, whether the mean mass of newborn babies are in a neighboring country B is different from country A. Okay, then maybe you can highlight the keyword different also. This is an important keyword that help us to decide our alternative hypothesis. Okay, so this is a keyword to help us and to decide the alternative hypothesis later. Okay, then now he chose a random sample of 16 newborn babies in country B and find their sample mean mass is 2.95. Okay, so sample mean mass. So that means this one basically is the sample mean, 2.95. Okay, and the sample size is 60. All right. So assume that your unbiased estimates in part A are correct values for mu and variance. Assume also that the variance of the mass of newborn baby in country B is the same as what we have in the country A. Okay, so carry out the test at 1% significance level. Alright, so basically for this one, we need to carry out a hypothesis test. Okay, so they want to test whether the mean mass for newborn baby in country B is different from what we have in country A or not. Okay, so first step, we need to set up the null and also the alternative hypothesis. Okay, so let's say I'm having the population mean for country B, right? Okay, I assume that it is equals to the mean in country A. So the mean in country A just now we calculate is 3.25, right? Okay, so this symbol means that the population mean of the newborn babies in country B is equals to the mean in country A. Then for alternative hypothesis, the keyword is different. We want to test whether is it different from country A or not. Therefore, the mu should be not equals to 3.25. Alright, so different, it can be more than, it can be less than from both directions, right? So when you want to write the alternative hypothesis, it should be not equals to. And please take note that this not equals to basically tell us that it is a two-tail test. Okay? Alright, then now they want us to carry out the test at 1% significance level, right? Okay, so after we set up the null and also the alternative hypothesis, then we can proceed to the next step. So for the next step, you basically need to find the critical value and also the test statistics if you want to use the critical value approach. Alright, so for me, my practice is usually I will try to draw a diagram for myself to understand it better. Since I know that this is a two-tier test, therefore I'm having two rejection region at both sides. So I'm having one rejection region on the right hand side, one rejection region on the left hand side. Okay, and then the significance level, right? The total area for both sides should be equals to 1% or 0.01. So which means that this area is 0.005 and this area is also 0.005. Okay, and then you need to know also from here that this is the critical value. Okay, this is the exact value, the critical value. Alright, and we need to find this critical value here. To find this critical value, again, because our table only provide us with the area smaller than, z smaller than a particular value, right? Equals to the area. So that means I need to refer to this whole area first. Okay, to find the critical value. So this whole area basically is center 0.99 because 1% is for the size, right? So the center here should be 0.99. So this whole purple color area here will be 0.99 plus 0.005. So you should refer to the area 0.995 for the critical value Z. So again, I have to go back to our MF19 booklet, then go for the normal distribution function table. So I'm looking for the area now, 0.995. If you want to make your life easier, maybe you can refer to the some critical value for the normal distribution. So let's look at this part, whether do I have 0.995 or not. Yes, we are having the area 0.995 and the expected value of Z should be 2.576, which means that my Z value here, or the critical value here, will be 2.576. Okay, since this is a two-tier test, right? Therefore, I have two value of critical value. Another critical value will be on this side and they are symmetrical. Therefore, this is negative 2.576. Okay, so I want to write inside my steps here. My critical value should be equals to plus minus 2.576. Okay, so this is the second step. We find the critical value for this 1% significance level test first. And after that, we want to find the test statistic. Okay, so for test statistic, right, because this question is testing for the population mean. Therefore, the test statistic for carry out this kind of test is you need a sample mean minus the population mean divided by standard deviation over square root n. So what is the sample mean? Second sample mean is given in the question just now, 2.95. This is a sample mean, right? Because all these values are taken out from a smaller sample, which is 60. The sample size is 60. Right, so the sample mean would be 2.95. Then minus the population mean. So the population mean should be 3.25 divided by standard deviation. So we already calculate the unbiased estimated variance just now in part A. And they also tell us that the variance of newborn baby in country B is the same as in country A. So that means I can use the result for variance in part 1 and substitute it here. So my variance is 1529 divided by 1996. Okay, this is the variance. When I take square root variance, it is a standard deviation, right? Then divided by square root n. So I'm having a square root still here, and then the n is actually 60. Okay, then for this particular test statistic part, use a calculator to help you, and then you should be able to get negative 2.655 as your test statistic. Or you can write it as negative 2.66 also can. Alright. Okay, then now I want to compare my test statistics with critical value so that I can make a decision for my test. Alright, or maybe make a conclusion for my test. Right, so I will observe negative 2.655, where is it located? So according to this normal graph here, negative 2.655 should be smaller than negative 2.576, right? Because this borderline here is negative 2.576. Therefore, my negative 2.655 should be even smaller than it. So I should label it like this. Okay, and then when you look at this purple line here, it actually falls under the rejection region, right? Because I told you just now, this is a two-tier test. Both sides we are having rejection region. So you can see that negative 2.655 fall under the rejection region. Therefore, you can actually make a conclusion that we have to reject the null hypothesis. Okay, but of course, before you need to make the decision, you have to write out a sentence for the comparison, a phrase for the comparison. So you can see that because the test statistics, okay, which is negative 2.655, is actually smaller than the critical value, which is negative 2.576. Okay, if you feel confusing on the comparison part, then it will be more helpful if you try to draw out a normal distribution diagram like this. At least you already know where is your rejection region. And then you can see the negative 2.655 falls under the rejection region. So to me, I think this one you can see it clearer. Alright, if you are confusing with the comparison method, then you can straight away draw a graph and then to help you better. So the shaded area here at both sides are actually the rejection area. And our test statistic falls under the rejection region. Therefore, since we know that test statistics fall under the rejection region, so we can make the simple conclusion where we should reject the null hypothesis. And then usually it will be good if you can write out a sentence or a conclusion, okay, according to the context of the question. So when we say that we reject null hypothesis, means that the alternative hypothesis should be accepted, right? Okay, so what is the conclusion that we can make in the context of this question? So when they say mean is not the same as 3.25, that means the mean mass of new babies in the neighboring country B is different from what we have in country A. Alright, so to make a simple conclusion, you can make it in this way. So after we carry out the test, right, it shows that there is enough evidence to show that, okay, the mean mass, so I would basically copy what we have in the question. So the mean mass of newborn babies in country B is actually different, okay, from that in country A. Okay, so to me, you need to actually write out the decision and then after that followed by a conclusion in the context of the question. So to me, this is a complete test that you need to show, okay, when answering the question. Alright, so first you need to show the null and alternative hypothesis. After that, the critical value and test statistics. Then you have to compare. You have to make sure that you compare the test statistic with the critical value, and only you make a conclusion and also decision. So this is how we answer question number 3. Okay, so let's discuss question number 4. We are having a number of X, which is the books are received at the charity shop, has a constant mean. So constant mean of 5.1 per day. Okay, so the keyword per day here actually tells us that it is a Poisson distribution. But of course, for this question, they are saying that tell you clearly also that this X is actually modeled by a Poisson distribution. They want us to state in context one condition for X to be modeled by a Poisson distribution. So basically for this one, right, you have to ensure that when the book receive, they should be received independently at different or maybe different days, right? So the books should be received independently. Okay, then now, since we already know that X can be modeled by a Poisson distribution, they want us to find the probability that exactly 10 books are received in 3-day period. Okay, so we are knowing that we are having 5.1 mean per day, and now we are interested to find the probability for a 3-day period. Therefore, we actually need to adjust the lambda to be used for the calculation. So it will be 5.1 for 1 day, and now I'm having a 3-day period, therefore I have to multiply with 3, where I get 15.3. Okay, then if we are having, okay, the lambda for Poisson distribution which is large enough, basically we can change it become normal distribution. Right, so if I want to change become normal distribution, okay, because for this question here, you can see that lambda is more than 15, right? So when the lambda is more than 15, basically you can approximate or change it become the normal distribution. Okay, so we try to make it become normal first, right? Okay, so I'm having normally distributed. So the mean should be 15.3, and then the variance should be also 15.3, because for this particular question, right, Poisson should having the same value for mean and variance. Therefore, mean is 15.3, variance is also 15.3. Alright, then now if I want to calculate the probability that exactly 10 books are received in a 3-day period, so I'm having X equals to 10. Okay, so this is actually a Poisson distribution. So for Poisson distribution, it is a discrete random variable. When you want to change it become normal distribution, it will be a continuous random variable. So I can write out this one. This is discrete, and then this is continuous. So when you want to change from discrete to continuous random variable, basically you need to apply continuity correction. So when I'm having x equals to 10, right? So this is x equals to 10, this is 9, and this is 11. To apply continuity correction, you need to make sure that the values are actually cover the value that you want to calculate. So this is actually 9.5 and this is 10.5. Okay, so that means I want to find out the probability where it should be between 9.5 to 10.5. Okay, then since I already make it become the normal distribution, right? To find out the probability in normal distribution, you need to standardize it first, where I take the x minus the mean divided by standard deviation. So standard deviation should be square root 15.3. And then z, and then 10.5 minus the mean divided by standard deviation. Okay, and then after that, I know that my value of z is actually between negative 1.483, also negative 1.227. Okay, so to find the probability for this area, I should take z smaller than negative 1.227 minus z smaller than negative 1.483. Okay, so to get this area 1.227, I have to use the normal table to find out. So 1.227 actually give me this one. So 1.22. So I'm having this value. Then add a 7. 7 is this one. You need to add a 13. Which means that I have 8888 plus 13. Okay, so by right, you should have 8901, right? Okay, so go back to our calculation here. Z smaller than negative 1.227, the error should be 1 minus 0.8901. Okay, because this is a small area. Reflect it to the right-hand side, you have to take 1 minus the big area. Okay, then minus the same thing happen here for negative 1.483. So again, I go to negative 1.483 and looking for 1.483. So 1.48 is this one, and then 3 is this. So you have to take 9306 plus 4, where you will get 9310. Okay, so and your probability here will be 1 minus 0.9310. Because this is a small area on the left, you reflect to the right hand side, you have to take 1 minus the big area. Okay, therefore you have to take 1 minus 0.9310. So for this particular question, you should have 0.0409. Alright, okay, so for this question, I'm applying the approximation. The reason is because of I noticed that I'm having a large value of lambda, which is 15.3. Okay, and then it has been more than 15. Therefore, I change it become the continuous random variable. Okay, so this idea basically comes from the A-level course book that we have. Okay, so I'm actually referring to this A-level course book for probability and statistics 2. And then if you have a look for some pages inside here, okay, let me enlarge it. So you can see that according to this book, right, for Poisson distribution, the mean and variance are the same. Therefore, when you want to change it become normal, both should be lambda. And then when can we actually approximate from Poisson to normal? You can see that the condition is here. For lambda greater than 15, the Poisson distribution with mean can be reasonably approximated by the normal distribution. Okay, so basically I'm referring to this course book to change the Poisson become normal in our discussion just now. Right, so let's go back to our question just now. So you can see that because our lambda already more than 15, therefore I change it become normal distribution and continue with the calculation. Okay, but according to the marking scheme that we can get from Cambridge website up to date, that means today is 13th of September 2023. Okay, the marking scheme basically didn't provide us with this kind of answer. That means they didn't approximate the normal, they didn't change the Poisson become a normal distribution. So maybe the reason is because of the lambda here is still not too far away from 15. So they still consider it as a Poisson distribution. Another reason is maybe they didn't mention clearly that you have to use a suitable approximating distribution to find the probability. Therefore, they didn't change it become normal. Alright, but no matter how, if I change from Poisson to normal distribution because of the reason that lambda is more than 15, then by right, this should be the answer. Okay, and now I'm going to show you the answer from marking scheme where they didn't change it become normal distribution and how will be the final answer look like. Okay, so you have to maybe copy down this part of the answer with the approximation one. Okay, and then now we have to just solve it by using the normal way where I didn't change Poisson become normal. Okay, and the answer that I'm going to show you now is what they provided in the marking scheme. Okay. All right. So if let's say I assume that the 15.3 is still not large enough to change the Poisson become normal distribution. So to calculate the probability, I want to calculate the probability for x equals to 0. So I still keep the x as a Poisson distribution. If I still keep the x as Poisson distribution, then the formula for the probability will be E negative lambda. Then you have to take lambda power 10 divided by 10 factorial. Okay, where comparatively you can see that the solution is much more straightforward and also much more shorter. Okay, so if I just press calculator and get this answer, it should be 0.0439. Okay, and basically this is what this is a solution that is provided in the marking scheme. Okay, and if you try to compare what I showed you just now by using the approximation and also the marking scheme, right, the answer actually is not very big difference. So just now I'm having 0.409 and you can see that this particular answer is 0.439. Alright, but in my opinion, basically when the lambda is more than 50, we can actually try to change it become normal. Alright, but for marking scheme, this is what we have. Okay, so I can't make any conclusion which answer is correct, but basically just to let you know that there are some options here, so there are some alternative here. Alright, so it depends on you whether which one you want to accept. Okay, right, then let's continue to part C. Okay, so for part C, we are having a suitable approximating distribution. Okay, I think the keyword is very obvious. So they did mention that we need to use a suitable approximating distribution to find the probability that more than 180 books are received in a 30-day period. Okay, so now I'm having 30 days period. Again, I have to change my lambda become for 30 days one. It is actually 5.1 for 1 day, right? Okay, so when I'm having a 30-day period, I have to multiply 30 with 1.5 and therefore I get a very large value which is 153. And then since the question already mentioned clearly that you have to use the approximating distribution, therefore I have to change become normal and then I'm having 153 and also 153 where the mean and lambda should be the same value. Okay, and then now I'm looking for the probability that x is more than 180. This is a Poisson, which is a discrete random variable. And if you want to change it become normal, which is a continuous random variable, then you have to apply the continuity correction. So to change it to make adjustment for the continuity correction, for this question, it should be 180.5. Okay, so since I change it become normal distribution already, so I have to standardize it before I can find out the probability. So I'm taking 180.5 minus the mean, so that means minus 153 divided by standard deviation, which is a square root of 153. Okay, then only you can try to get a value of z, which is 2.223, correct to 3 decimal places. And then 1 minus, now I'm looking for z smaller than 2.223 from the normal distribution table. So 2.223, this is 2.22, this one 9868, then 3 is a 1. So 9868 plus 1, you have 9869. So that means in our calculation here, you need to take 1 minus 0.9869. Okay, then final answer correct to 3 significant figure, it should be 0.0131. Alright, so this is the correct, the complete solution for the part C, where we are trying to change the Poisson become normal distribution. Okay, then we still have one more part to go, part D. Okay, so for part D, now they're talking about the number of DVD received at the same shop is also modeled by independent Poisson distribution, and then with the mean 2.5 per day. Okay, so just now maybe we are having what? We are having CD, is it? I forget. Oh, they are talking about the books. Just now they are talking about the books, and then the mean is 5.1. And now they are talking about DVD, and the mean is 2.5. So just now for the books, I'm using it as X. So maybe this one I'm using it as Y. Okay, then now they want us to find the probability that the total number, highlight the keyword total number, okay, total number of books and DVD. When I want to write out the mean, okay, or maybe when I want to write the symbol for books and DVD, total number means you are taking the number of books, which is X, plus the number of DVD, which is Y. So that's the meaning for total number of books and DVD, X plus Y, that are received at the shop in one day is more than 3. So one day is more than 3. Okay, so our calculation for the probability is based on this one day. Okay, so first of all, I want to know what is the total mean for X and Y for one day. Okay, so to get the X and Y, since both are Poisson distributed, right? So this is still a Poisson distribution. And then the mean for books is 5.1. The mean for the DVD is 2.5. So when you add them together, the new mean that we get here is actually 7.6. So they want us to calculate the probability that the number of books and also the DVD more than 3. So X plus Y more than 3. Okay, then again, I cannot calculate the probability for Poisson that is more than. So I have to take 1 minus X plus Y smaller or equals to 3. Okay, then to calculate this probability, what I need to have here is, okay, E negative lambda, so negative 7.6. When X plus Y equals to 0, it is always a 1. X plus Y equals to 1, it is lambda. X plus Y equals to 2, it will be 7.6 lambda squared divided by 2 factorial. And then X plus Y equals to 3, it will be 7.6 power 3, then divided by 3 factorial. Okay, so again, pressing the calculator very carefully, and finally you should get the answer 0.965 correct to 3 significant figure. Alright, so this is talking about the total number of Poisson distribution where you are having books and DVD, and when you write it out, it should be X plus Y. Okay, alright, so this is how we answer question number 4. Okay, so we come to question number 5. We have two random variables X and Y. They are independent distribution, and then both of them are normally distributed. A random variable of each variable is taken. Then they want to find the probability that the two values differ by more than 2. The difference between the two values. When you want to write the formula for the difference between the two values, right, it can be X minus Y. It can be also Y minus X. Okay. So when you want to calculate the probability, we can write out the probability of X minus Y greater than 2. We can also write out the probability that Y minus X greater than 2. That means we want to find out these two possibilities, the probability for these two possibilities. Okay, but for most of the time, when they are asking for differ, right, X minus 1 and Y minus X, I can actually combine them, become the modulus of X minus Y. Okay, so later when I want to write out my solution for calculation, basically I'm using the modulus function, so modulus X minus Y, which means that you can take X minus Y or you can take Y minus X. Okay, so since I already know that I need to calculate the probability for X minus 1 later, so first I will want to find out the mean for X minus Y first. So what is the mean for x minus y? So basically it should be min x minus min y. So it will be 7 minus the 6 where I get a 1. And then when we are talking about the variance x minus y, it should be variance x plus variance y. There's no minus in variance, right? So variance x is 3 plus variance y is 2. Then basically you're having a 5. X is normally distributed, y is also normally distributed, so their linear combination x minus y is also normally distributed with mean 1 and also the variance 5. So this is basically what we have. And then they want us to calculate the probability that the two values differ by more than 2. So like what I mentioned just now, it can be x minus y or y minus x. Therefore, when I write out as x minus y modulus, then greater than 2. So according to what we learned earlier in pure maths, so I'm having x minus y greater than 2. Then another option is x minus y smaller than negative 2. So x minus y smaller than negative 2. Okay, so since I know that x minus y, right, basically they are normally distributed. Therefore, to find out the probability, I have to change it become z. So I'm taking the value of 2 minus the mean, so minus a 1, divided by standard deviation, which is a square root 5. 5 is a variance, right? So divided by standard deviation will be square root 5. Same thing happened for the second part here. X minus y, you have to change it become z. So how to change it become z? You take negative 2 minus the mean, minus the 1, again divided by standard deviation, which is square root 5 as well. Okay, so from here you get z greater than 0.447 and also z smaller than negative 1.342. Okay, then after that you want to find out the probability from the normal distribution table. So looking for 0.447, and for this area you have to take 1 minus, because it is z greater than 0.447. From our table it can only provide us with smaller than value, right? Okay, so looking for 0.447. So maybe I try to erase everything here first. 0.447 where you are. Okay, so 0.4. So 0.44 is this one. Then 7 is this one. So you have to add 25 and the last two digits of 6700. Okay, so it will have 6725. Okay, then in my calculation here, it will be 1 minus 0.6725. Then plus, now I'm looking for negative, smaller than negative 1.342. Also need to take 1 minus, because when you reflect this negative value to positive side, it is a small area. So I have to take 1 minus the big area together, correct answer. So 1.342. Go for 1.3, then 4 is this one, then 2. That means you need to add a 3. So 9099, you add a 3, become 9102. So you have to take 1 minus 0.9102. So simplify the answer. By right, you should get 0.417, correct to 3 significant figure. Okay. Alright, so basically this is how we answer this question. Then let's proceed to the next part, part B. Okay, so now they're talking about candidates' overall score in the SCIENCE test is calculated as follows. The mark for theory is denoted by T, practical is P, overall score is given by T plus 1.5 P. Okay, then the T and P are independent. Both of them are normally distributed. So there's no continuity correction are needed when you use all this distribution. Okay, a pass is awarded to candidate who score over 90 or at least 90. Find the proportion of candidates who pass. Okay, so they're asking for the probability of the candidate that passed the test. Okay, so first of all, we know that to pass the test, the total score should be more than 90, right? So I need to know what is the mean and variance for total score first. So to get the mean and variance for the total score, mean for total score is theory plus 1.5 times of practical. Mean of theory is given here, which is 62. plus 1.5 times of practical. So the mean for practical is 4.2. So from here, you should get 125. Sorry, it is not 4.2. There's an error here. It should be 42, right? Yeah, so when you simplify the value here, it should be 125, which is the mean for theory plus 1.5 practical. And then now, if I want to calculate the variance for t plus 1.5 practical, variance of t is 158 plus, you have to take 1.5 and you square it. Because the 1.5 here means the 1.5 times of the practical mark. Okay, when you involve anything with times, right? So your variance, when you want to calculate the variance, you have to take out the constant by squaring the constant. So I'm having 1.5 square. Then the variance for P is 108. So from here you will get 401 for the new variance. Okay, so from here you already can see that the T plus 1.5P, T is normally distributed. P, 1.5P is also normally distributed, right? Okay, and this is a linear combination of both normal distribution. So end up the result is also normally distributed. So I'm having the mean 125. Variance should be 401. Okay, then again, calculation for the probability. They are asking for the total score, which is T plus 1.5P, and this 90. So it should be greater or equals to 90. I know that this whole thing is normally distributed. To calculate the probability, I have to change it become Z. So I take the 90, you have to standardize it. So minus the mean divided by standard deviation. Okay, so what is the Z here? So the value of Z will be greater than negative 1.748. Okay, so Z greater than negative 1.748 is a large area. It is equals to Z smaller than 1.748. So again, I go for 1.74 is this one. Then 8 is this one, right? Plus 7. So 9591 plus 7 at the last digit. So it should be 9598. And of course, I want to correct it to 3 significant figure. It should be 0.960. Correct to 3 significant figure. Okay, so this is how we answer this part. Okay, so let's proceed to part number 2. They want us to comment on the assumption of the variable T and P are independent. Is it possible that the theory mark and practical mark are independent or not? Okay, so it is unlikely. So for me, I would say that it is unlikely to be independent between the theory and practical. Because usually you can see, if let's say the student is good in theory, right, then the practical will not be too bad also. Okay, so this is usually now, right? So for me, I'm saying that a candidate, okay, who score good or who score well in theory, usually, okay, will be doing well also in practical. This is by common sense, like what we can observe in real life, right? Usually it's like that. Usually when your theory is not too bad, then the practical also quite okay. It is quite impossible that your theory is extraordinary good and then the practical part is very, very bad. Okay, so for me, I would say that it is unlikely to be independent. Okay, so this is how we answer question number 5 for this paper. Alright, so now we are at question number 6. When a child completes the online exercise, they might be awarded a medal. So the publisher claimed that the probability of random chosen child who complete a math lit will be awarded the medal is 1/3. So the proportion to get the medal is 1/3. And then Asha wished to test this claim. She want to test the claim. She decide if she awarded no medal while completing the 10 mathematics, she will conclude that the true probability is less than 1/3. So this less than 1/3 is an important keyword that tell us about the alternative hypothesis. So by right, you should actually know some, you need to have some idea about the hypothesis on this test. Okay, so basically they are going to test the probability of getting a medal. Okay, so our null hypothesis will be having the probability of equals to 1 over 3 lah. And then she want to test whether this is true or not, and the alternative is given here, less than 1 over 3. So P is smaller than 1 over 3. Okay, and then what else can we get from this paragraph? Okay, so later we'll try to read through it again. Now they want us to use a binomial distribution to find the probability of a type 1 error. Okay, so they actually want us to calculate type 1 error. How can we calculate the type 1 error? So we need to know the definition for type 1 error first, where type 1 error is actually we reject the null hypothesis when the null hypothesis is true. Okay, so if we want to calculate anything that is related to reject the null hypothesis, right? Basically, I need to have the rejection region. Okay, so how can I get the rejection region? So we need to go through with the question again and see whether did they provide us with the rejection region or not. Okay, so let's read the question one more time. So we start from here. Asha wished to test the claim. She decides that if she is awarded no medal, okay, no medal while completing 10 metrics, she will conclude that the true probability is less than 3. Okay, so look at this one. Conclude that the P is less than 3. That means they are saying that this is correct if she wins no medal when they try to complete 10 metrics, right? Okay, so what does this mean? So basically this one means that I accept the alternative hypothesis when no medal is won if I play 10. Okay, and then if I accept this one, that means that no medal means x equals to 0, okay, will be your rejection region, because when x equals to 0, you reject the null hypothesis where P equals to 1 over 3, and you conclude that alternative hypothesis is correct. Therefore, x equals to 0 will be your rejection region. Okay, because when x equals to 0, you ignore or you reject the null hypothesis and you accept the alternative. Okay, so this is actually the rejection region given in the question. And now I want to use this rejection region in my calculation for type 1 error. So reject null hypothesis will be x equals to 0. Given that the null hypothesis is true, that means I'm having P equals to 1 over 3. How can I calculate this probability here? They already give us a very clear hint to use a binomial distribution. So if you want, you can write a small symbol here to remind yourself. X is X is binomial distributed. The total number of games that I play is 10, and then the probability of winning the medal is 1 over 3, because null hypothesis is true, therefore it is 1 over 3. So what is the probability for x equals to 0 for this binomial distribution? So it will be 10 C0 and then P power 0 and Q power 10, right? According to the formula that we learned in binomial distribution, suppose this is the formula that we have, okay? Then by just pressing calculator, the answer that you get for this type 1 error should be 0.0173. Okay, so before you want to calculate the type 1 error, right, basically you need to know the rejection region first. So you can usually go through again with the question and see whether did they provide us with any rejection region or not in the question. Okay, then since they already tell us that we are using binomial distribution, so this is a binomial distribution that we have with the parameter 10 and 1 over 3, then you can continue to calculate the probability by using binomial formula. Alright, okay, then after that we proceed to part B. So this is type 1 error. Then for part B is type 2 error. So now they are saying that the true probability of being awarded medal is denoted by P. Given that the probability of type 2 error is 0.8926, find the value of P. Okay, so they give us the type 2 error probability, which is equals to 0.8926. So first, start from this information given. I want to further interpret the type 2 error. So type 2 error will be accept null hypothesis false equals to 0.8926. So this is the definition for type 2 error. Okay, then accept the null hypothesis means that I have to put in the acceptance region. Acceptance region. Just now in part number 1, right, part number A, our rejection region is x equals to 0. That means for acceptance region, it will be the opposite meaning of rejection region. So it will be x greater than 0 or x greater equals to 1. And now they said the null hypothesis is false. So that means I need to have a new probability. And this tells us that it is given by the P. The correct true probability is P. Okay, and it is equals to 0.8926. Again, to calculate this probability, it is actually still binomial distributed with the 10. Okay, you are playing 10 games, and then the P now become don't know. And I want to find the P here. So next one, how can I calculate the probability for x greater than 0? So that means I have to start from x equals to 1, x equals to 2, x equals to 3, and then x equals to 10, which is quite long, right? So for this one, I'm using 1 minus x equals to 0. So I take 1 minus x equals to 0 will be 10C0. What is the value for P? I don't know, so I put it at 0. What is the value for Q? I also don't know, but I know that it is 1 minus P, then power 10. And it is equals to 0.8926. Okay, then I try to simplify and rephrase my answer here. I take 1 minus 0.8926, I will get 0.1074. Okay, so continue from here. 10C0 is a value 1. P power 0 is also a value 1. Therefore, to calculate the P, right, I have to bring the 10 over, where it is actually 0.1074 power 1 over 10. And after that, you can try to get the value of P by taking 1 minus the answer on the right hand side. So you get P. 1 minus P equals to 0.8. So from here, you're able to get the value of P, which is equals to 0.2. Alright, so this is how we get the answer for question number 6. Okay, so the acceptance region is the opposite meaning of rejection region, and the rejection region is already provided in the previous part. Right, so this is how we apply for the calculation to get the value of P. Okay, so now we are at the very last question for this paper. Okay, question number 7. We are given a diagram, and then it is actually the PDF for a random variable x, which take the value from 0 until 4. So you can see very clearly that our graph start from 0 until 4 only. Okay, between these two values, the graph is a straight line. So they want us to show that fx equals to kx for 0 until 4, where k is a constant to be determined. Right, so we need to determine the constant here, the k. Okay, so there are many ways to solve this kind of question. Alright, so for me, I'm using the concept of the area under the graph for PDF. So this is the area of triangle under the function, right? Okay, and I know that the total area under the graph should be equals to 1. Okay, so which means that the area of triangle should be equals to 1. Okay, so how to calculate the area of triangle? We are taking the half multiply the base. The base here is actually a 4 unit. What is the height for the triangle? So the height of the triangle, I don't know. So maybe I can just label it as y first. So I'm having a y here, and therefore it is equals to 1. From here, very easily, I will get the y, which is equals to 1 over 2. Okay, and then to get the function fx, which is equals to kx, you can see very clearly that this is a linear line, right? This is a linear line. So k is actually the gradient of this linear line, because y equals to mx plus c, right? So there's no intercept of y because it passed through the 0. Therefore, this straight line is actually kx, kx where the k is a gradient. So now I want to use the concept of gradient here. So what's the gradient, formula for gradient? To calculate the gradient, right, basically it is the value of y divided by the value of x. So gradient is actually y divided by x. So what's the value of y that we get just now? Half. What's the value of x for our triangle here? 4. So our gradient for this question should be 1 over 8. Therefore, the function f(x) can be written as 1 over 8x. Okay, because the k here basically is the gradient, right? Okay, so this is what we have for part A1. Let's proceed to part number 2. Okay, so for part number 2, hence or otherwise, they want you to find the expected value of x. Okay, so for information, for a continuous random variable, to calculate the expected value of x, right, you need to integrate the function x multiplied with fx for all the value of all the limit of the x, okay, provided in the question. So this is a general formula. Okay, so to write out the formula for our question here, our value of x is from 0 until 4. And I need to take the x multiply with fx. Our fx just now is in part 1, which is 1 over 8x. Okay, then usually before the integration, I prefer to take out my constant one. Usually it's like that. Then I multiply the x together, become x squared. Then only I start the integration. So integrate x squared, I'm having x power 3 divided by 3. Then substitute in the value 4 and 0. I will take out the constant again. So it becomes 24. Then 4 power 3 is 64. 0 power 3 is a 0. So from here, if I try to simplify the answer, 8 over 3 will be the mean for the x. Okay, so this is how I answer part number 2, A2. Okay, proceed to the next part. Okay, so part B, they provide us another diagram here, which is the function g. And then they said, takes the value between 0 and a, and also the a is a positive value. Between these two values, the graph is a straight line again. So given that the median of w is 1, find the value of a. Okay, so what we know here is they are talking about median. So for the median, right, basically it means that this is the median one, and this area is 0.5, because median is actually the value that is 50% in the center of the whole value, right, whole graph. Okay, so that means when I'm having a 1 here, the area on the right hand side of 1 is 0.5. The area on the left hand side of the 1 is also 0.5. So that's basically the meaning of the median. Okay, then they want us to find the value of a. Again, for this question, there are many ways for us to solve it. Alright, then I'm still using the area concept and also the ratio of the triangle that we can see later. Right. Okay, so first of all, we are talking about area. I know that the area of the area of triangle should be equals to 1. Okay, so what is the area of triangle? So half times base. So my base here is this one, from 0 until a. So I'm having the a times height. What is the height here? This is the height. I don't know the height, so I put it as a y. And this is equals to 1. Okay, so from here, I'll get my y, which is equals to 2 over a. Okay, if my y is 2 over a, right? So basically, you should know that the y-intercept here is actually 2 over a. The height, right? Okay. Okay, so this is basically the very first equation that we have, y equals to 2 over a. And then now, to find the value of a, I need to create more equations so that I can solve that simultaneously, right, to get the answer. So what I want to do now is I'll try to compare the two triangles. So I'm having two triangles here. One is a big triangle, this one in green color. Another one is a smaller triangle in the highlighted line. Okay, so I'm using the ratio for these two triangles to form another equation. Okay, so maybe for me, I'm using the ratio of triangle. Okay, so for the bigger triangle, the height is 2 over a, right? So I can write the height is 2 over a divided by the base. The original base here is a. Then equals to, now looking at the smaller triangle, the height I don't know. So I put it as a y. And then the base is actually from 1 until a, right? So if you write out, it should be a minus 1. Okay? Then if I try to simplify this equation, now I'm having 2 over a squared equals to y over a minus 1. Then I get the y, which is equals to 2a minus 1 divided by a squared. Okay, so I write this as a maybe one equation or the star equation. Okay, so please take note that the y here, right, is actually this value, this height. This height is the y. Okay, this one. Yeah. Alright, so this is the first equation that I get. So this y and this y are two different things. This y basically is the height for the larger triangle. This y is the height for the smaller triangle. Okay, then now again, from this smaller triangle, I can form another equation where the area of the smaller triangle, right, is equals to 0.5. Because I know that it is a median at 1. So this area is 0.5. Okay, so I can form another equation for the smaller triangle. For the small triangle, I know that half times base times height should be equals to 0.5. So what is the base? The base is from 1 until a. So it should be a minus 1. What is the height for the small triangle? The height for the small triangle is this one. So I substitute it in 2a minus 1 divided by a squared, and I get it equals to 0.5. Okay, or maybe if you want to put it in a fraction form, so the 0.5 can be written as 1 over 2. Okay, so this is a small triangle. So basically, I already substitute the y by using this equation that I get just now. Because I know the y here is the height for the smaller triangle, right? And now we are calculating the area for the smaller triangle. So this is how I substitute it inside here. Okay. Alright, then you can see that now I already have one equation that is in terms of a. So you try to simplify the whole equation here. Half and half can be cancelled off. Expand the a minus 1 divided by a squared. Okay, so if we didn't do any careless mistake, okay, let me have a look. What do I have here? So I'm having 2 times of a minus 1 squared equals to a squared. Okay, I move the a squared over, become 1 times a squared, I get an a squared. Then a minus 1 and minus 1 multiply together become a minus 1 squared. Okay, if I try to expand this equation, right, by right, I should have 2a squared minus 4a plus 2 equals to a squared. Further group them together, I'm having a squared minus 4a plus 2 equals to 0. And now I want to get the value of a. So to get the value of a, this equation cannot be factorized. So to find the value of a, I have to use the quadratic formula, where a is negative b plus minus square root b squared minus 4ac, then divided by 2a. From here, you'll get two values for a, which is 3.41. Another value will be 0.586. We have to ignore this value for the a. Okay, so we only accept a equals to 3.41. Okay, so now why do we need to ignore the second answer here, which is 0.586? Okay, the reason is if you try to substitute this value, okay, into the y, we are having the smaller y height. Y is the smaller height, the height for the smaller triangle, right? If I substitute a equals to 0.586 into the calculation here, you will get the negative value. Okay, but according to the diagram here, my height for the smaller triangle is actually positive value. Okay, so if I substitute the A into this equation, I get a negative value. Therefore, this is not the correct answer, and our answer accepted is only 3.41. Okay, right, so this is the suggestion for us how to find out the value of A for this particular question. There are more than one method to solve this question. Okay, so some students are using some other information, but maybe they are using the large triangle, or maybe they are using the trapezium area to find out the A, which is also a correct method lah. Right. Okay, so for me, I focus on the triangle and also the area of triangle and also the ratio. Alright, for the big and small triangle to get the answer for A. Okay, so here we ended our discussion for this paper, Statistics 2 paper, right? Stats 2 paper. Alright, so thank you very much for watching this video.